guys, you're welcome to today's episode on data augmentation. Data augmentation is a technique used to artificially increase the size of datasets by applying transformations such as rotation, scaling, flipping, zooming, and so on to the original image or images. So in this video, I will explain one of the ways of data augmentation for your image. More so, you'll be able to understand how each of the transformation works on an image. Additionally, do well to watch the next video on data augmentation, part 2. This will explain the technique in increasing dataset during training in machine learning. So let's get started. So I will import libraries. So we have from TensorFlow, there's Keras, there's pre-processing, there's image. So I will import image data generator. So this image data generator is a class from the Keras library used for data augmentation. So next I have from matplots lib.pyplots. I'm going to import imread to read the image, imshow to display the image, subplots to plot the image, and show. Okay, so the next line of code will define the function plot that takes in an object of the image data generator class and will plot 4 images generated by this image. So this function will start by calling a fit method. We have data generator dot fit. Here we have images. Okay, so the function starts by calling a fit method on the input data generator object with the images data. So this method is used to configure the internal parameters of the generator based on some sample data. So next, the flow method is called on the data generator object with the images data. So we have image iterator, data generator dot flow images. So this method will return an iterator over the images generated by the generator. So we'll move over to have a plot with 1 row and 4 columns using the subplot function from the matplotlib library. So we have fig rows, subplots, okay. The number of rows, n rows, will be 1, and the number of columns, which is n columns, will be 4, and the fig size will be set as 18 by 18. Okay, so we'll go ahead to say for rows, row in rows, we're going to have row.imShow method on each row of the plot to display the image from the iterator. So that's next, square brackets 0 dot as type int. So next will be the axis method, which will be used to turn off the axis. So we have row.axis, we'll set it as off, and lastly will be show. So let's go ahead to read the image. So we have image, read. We introduce our raw string, then locate the file. So I will be using this car and the format is JPG. I'll copy that, then paste. So moving over to reshape the image data using the SciPy library into a 4-dimensional tensor with shape. So we'll have images, image.reshape 1. We have the image.shape square bracket 0. This represents the height, this represents the width. Lastly, the channel. And lastly is to display the original images using imshow method. So we have imshow images. And we'll go ahead to do the show method in order to display the plots. So let's see what we've got. Okay, so we'll be able to do that. So let's move to the next thing. So we want to see the output of each of the transformation using the image data generator. So let's go with that. So we have image generator equals image data generator. So the first transformation will be the rotation range. So we'll set the parameters as 40 and I'm going to plot that. So this will display the generated images with rotation in a plot. So let me run that. Okay, so you can see when we use the rotation range, we're going to have this. Okay, so let's try another one. Let me just copy this and paste. Let's try the width shift range, and we'll set this as 0.2. So let's see. So you can see we did a width shift range. We can as well try the height. So let me copy that and paste. So if we go ahead to do for the height, let's see what we've got. So this is for the height. So you can see the operation being done. And another one I would love us to also try is the zoom range. The zoom range. So let me change this to zoom. So for the zoom range, let me run that. Okay, so this is what we'll get when it is zoomed. And then we can look over on horizontal flip. We also have the vertical flip. This we are going to set it as true. So let's see. Okay, so this is for the horizontal flip. There are more transformation, like you can also try the rescale, the share range, the fill mode, and so on. So these are the results we are going to have in each transformation. These are the results. I decided to explain how this result looks like because most times in machine learning code, when the different transformation are being done using the image data generator, we can put up to as much as we want. So it's going to just save in the folder together. So you wouldn't tell which particular transformation it's that or which technique have been performed on that. So I decided to explain first in this part 1 the result of each technique. So you can watch the part 2 of the data augmentation, how this data are being increased. You can see the results in the folder and which is being used in increasing our data sets. in a situation we have limited data. So this is one of the best traditional strategy of increasing or augmenting our data sets when training with machine learning models. Okay, so thank you for staying and watching through to this point. Please don't forget to subscribe, like, comment, and share. Also, remember to hit the notification bell so as to get updated on forthcoming videos. Additionally, I will include the GitHub link for this code in the description below. Bye guys, I'm signing off now.